In today's class, we will discuss about the properties of quadrilaterals. Quad means four, lateral side, so four-sided figures. Quad means four, lateral side. So we are discussing about four-sided figures. Now, what are the four-sided figures? We have got a square, rectangle, trapezium, parallelogram, etc. Let us broadly classify this quadrilateral. Take down. Quadrilaterals into two types. Concave quadrilateral, convex quadrilateral. Concave quadrilateral, concave means there will be a cavity, that is, it will be like this, 1, 2, 3, 4. This is called concave. Convex means, that is, this is convex. That is, two sides are making an angle like this, and here all are convex only. In the case of concave quadrilateral, one interior angle is bigger than 180 degree. In this case, these are interior angles. Which are interior angles? 1, 2, 3, 4. So, one of the interior angles will be greater than interior angle. One of the interior angles, any one interior angle is greater than 180 degree. It is greater than 180 degree. That is, here all interior angles are less than 180 degree. Are you able to follow? Now we are going to discuss about convex quadrilateral. Convex quadrilateral. This convex quadrilaterals here will be discussing the basic terms involved here. Then we will discuss about the angle sum property of quadrilateral. What is that? Angle sum ASPQ, angle sum properties of quadrilateral, property of quadrilateral. Then we will discuss about the type of quadrilaterals, different types. Then we will discuss the midpoint theorem and its converse. And its converse. Under the types of quadrilateral, we have parallelogram. Parallelogram. Parallelogram means it is like this. That is, opposite sides are parallel and equal. And we have trapezium. So trapezium will be like this. This is trapezium. So here two opposite sides are parallel and another two opposite sides are not parallel. Then we have kite. So it will be like this. So here the adjacent sides are equal. This is kite. And under parallelogram we have the following. That is, rectangle is one of the parallelogram, but what makes the difference? Opposite sides are equal and all angles are equal, that is perpendicular, 90 degree. Okay, so this is rectangle, right? And then we have square. All sides are equal and 90 degree. All angles are 90 degree. And we have, this is square. Okay. Then we have rhombus. All sides are equal, but they are not rectangle. They are not perpendicular. That is 90 degree. But opposite angles are equal. This is called a rhombus, or H-O-M-B-U-S, rhombus. Now let's have the summary of properties of all the quadrilaterals. Okay, we will start from parallelogram. Properties of parallelogram. Here parallelogram, first you draw the diagram. This is the parallelogram. You have A, B, C, D. Take down two pairs of sides of equal length. Two pairs of sides. It has two pairs of sides. Okay, what are those two pairs? This is one pair, another pair. Two pairs of sides of equal length. It means AB is equal to DC. BC is equal to AD. Then two pairs, it has two pairs of parallel sides. Parallel sides. It means AB is parallel to DC and BC is parallel to AD, right? Opposite angles are equal. Opposite angles are equal. What do you mean by this? Angle A is equal to angle C. Angle B is equal to angle D. Okay. So opposite angles are equal. Diagonals that bisect each other. So it has diagonals. Parallelogram has diagonals that bisect each other. What do you mean by this? Now you have the diagonal AC. AC is a diagonal. Another diagonal BD, right? And here this AC divides the BD equally, correct? Similarly, this BD divides the diagonal AC equally. Okay, and that is why we say diagonals that bisect each other. So what are the diagonals? AC and BD are diagonals. And they intersect at a point O. So they bisect each other. It means AO is equal to what? OC. Similarly, BO is equal to OD, right? Next, they have no lines of symmetry. You cannot see the symmetry here, but it can have two rotational symmetry, that is order. It has order, two rotational symmetry. Okay, so symmetry means what? For example, let us consider a human being. A human being has two hands, two legs, and you can completely bisect the human into two equal parts, like a mirror image. So it has got the vertical plane of symmetry, every human being. So there must be some symmetry. When you consider the rectangle, you have the symmetry. You can cut it into two equal halves. Similarly, you can cut it into two equal halves. But in the case of a parallelogram, you cannot cut it into equal part. Okay, you cannot cut it. And that is why no lines of symmetry. Okay, but it can have rotational symmetry. Rotational symmetry means, now let me take one. This is the parallelogram. Okay, now let us rotate like this. Are you able to get the equal type? No. This one you will have, but in the opposite it is non-superimposable, and when you rotate like this you cannot. So it means that is, it has the order of 2 rotational symmetry. Next, now let us consider square. The properties of square. A, B, C, D. Okay. Now, a square has all sides the same length. Same length. All sides are equal. AB is equal to BC is equal to CD is equal to AD. Second, it has 2 parallel sides, 2 pairs of parallel sides. 2 pairs of parallel sides. It means AB is parallel to CD. Another element of the pair, BC is parallel to AD. So 2 pairs of parallel sides. Got this point? All angles 90 degree. It has, square has all angles 90 degree. It means angle A is equal to 90 degree, angle B is equal to 90 degree, angle C 90 degree, angle D 90 degree, that is 90 degree, 90 degree, 90 degree. Okay. Then opposite, the diagonals bisect each other here. What are the diagonals here? AC is the diagonal, BD is the diagonal. They bisect each other. Okay, take down. Squares have diagonals that bisect each other. Right? At 90 degree, that is important. At 90 degree. And they have 4 lines of symmetry. So you can split it into 2 equal halves, 2 equal halves, 2 equal halves, and diagonally 2 equal halves. It means 4 lines of symmetry. Do you understand? See, you can split like this. Are you able to get 2 equal shapes? You can split like this. Are you able to get 2 equal shapes? You can split like this through the diagonal to get the equal shapes, triangles. And here another set. So likewise you have 4 lines of symmetry, and it has 2 rotational symmetry. So order, it has order 2 rotational, not only 2, 4. It has order of 4, rotational symmetry. It means you can rotate 4 times to get the equal shapes. Okay. Now let us move to the next shape. Rectangle. A rectangle has A, B, C, D, 4 angles. So a rectangle has 2 pairs of equal length. Okay, 2 pairs of sides of equal length. Equal length. It means AB is equal to CD, BC is equal to AD. So 2 pairs of equal lengths. Next, it has 2 pairs of parallel sides. Pairs of parallel sides. It means AB is parallel to CD, AB is parallel to CD, BC is parallel to AD. Right? Another 2 pairs. Then all angles 90 degree. It has all angles 90 degree, 90 degree, 90 degree, 90 degree, 90 degree. So angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. They are all right angles. It has diagonals. It has diagonals that bisect each other. Bisect means what? Bisect means what? Divide equally. So bisect each other. So it has the diagonal AC that bisects the diagonal BD equally. Okay. Similarly, AC divides BD equally. AC, BD, they are diagonals and they meet at point O. So AO is equal to OC, BO is equal to OD. Okay. Then they have 2 lines of symmetry. It means you can divide like this, okay, equally. So, and rotationally order 2. So it has the order 2 rotational symmetry. Okay. Shall we move to the next quadrilateral? Rhombus. So the rhombus will be like a parallelogram, but they are of equal sides, like a square. A rhombus has all sides the same length. Okay, it means AB is equal to BC is equal to CD is equal to AD. Rhombus has two pairs of parallel sides. Two pairs of parallel sides. It means AB is parallel to CD. Then BC is parallel to AD. So a pair, two pairs. Then opposite angles are equal. Opposite angles are equal. It means angle A is equal to angle C. Angle B is equal to angle D. Next property, diagonals that bisect each other. They have diagonals. They have two diagonals that bisect each other. So what are those two diagonals? We have AC and BD. AC is divided equally, BD is divided equally at O. So it means AC, BD are diagonals and they bisect each other, means AO is equal to OC, BO is equal to OD. Okay, and in this case no lines of symmetry. But it has order 2. Order 2 rotational symmetry. Now let us move to the special type, that is kite. Here kite will be like this. So here two pairs of equal sides, it means the adjacent pairs are equal. Let me consider A, B, C, D. AB is equal to CD, BC is equal to AB is equal to AD, BC is equal to CD. Do you understand? No parallel sides. You cannot see any parallel lines here. Okay, it has no parallel sides, but it can have one pair of equal angles. Equal angles. it means this angle will be equal. Angle B is equal to angle T. But angle A is not equal to angle C, right? And it has one diagonal that bisect each other. It can bisect the entire quadrilateral, the kite, equally. Even though it has two diagonals, one diagonal, the other diagonal does not bisect. Are you will follow? So one diagonal, it has two diagonals. What are those two diagonals? That is AC and BD, right? This AC bisects, okay, AC bisects BD, right? Let me say this is O. Remember, OD is equal to OB, but OA is not equal to OC. Do you understand the meaning? Okay, even though it has got two diagonals, only one diagonal that bisects the other diagonal. So in this case, the diagonal AC bisects BD. It means OB is equal to OD, but BD does not bisect the AC. Do you understand this point? One diagonal bisects the other. Okay? And the diagonals, they cross at 90 degree. Two diagonals, they cross at 90 degree. So this angle is 90 degree. AOB is 90 degree. BOC is 90 degree. AOD is 90 degree. Okay? And it has one line of symmetry. It means you can cut it to two equal halves vertically, and it can have the order of one rotational symmetry. Are you able to follow? Now let us move to the next quadrilateral, trapezium. Okay. Let us say trapezium. A trapezium has sides of different lengths. So AB need not be equal to BC. BC is not equal to CD. CD is not equal to AD. But they have one pair of parallel sides. So what are the parallel sides here? AB is parallel to CD. Okay. But non-parallel lines, BC and CD are non-parallel. BC and CDA are non-parallel lines, sides. Which are the parallel sides? AB and CD. And they have different angles. Different angles. What do you understand from this? A is not equal to B, that is not equal to C, that is not equal to angle T, right? All are different. Okay? And you cannot have any line of symmetry. So no line of symmetry. No lines of symmetry. You understand? No lines of symmetry, but has order 1 rotational symmetry. Now let us discuss the last one. Isosceles trapezium. Isosceles trapezium. Iso means same, celes sides. So two sides are equal here. So it means you have two opposite sides equal. That is AB, CD. Here AB is equal to AD is equal to BC. Okay. So it means it has two sides the same length. What are those? AD is equal to BC. These two are equal. But AD is not parallel. Okay? AD is not parallel. AD and BC are non-parallel. Are you able to follow? But AB is parallel to CD, but AB is not equal to CD. Do you understand this? So it means it has one pair of parallel sides. And which are those? That is AB and CD. They are parallel. And it has two pairs of equal angles. These are equal. Similarly, these two are equal. C, D are equal. So it has two pairs of equal angles. It means their opposite angles are equal. Opposite in the sense along the line. So AB, angle A is equal to angle B. Angle C is equal to angle D. Right? And it has one line of symmetry. And order 1 rotational. One rotational symmetry. Okay. So let us continue in the next class. And before that, you should be aware of some fundamental terms. I will include that one also. Let us consider a quadrilateral. A, B, C, D. So here it has 4 vertices. Vertex. Vertex means A is a vertex, B is a vertex, C is a vertex. Okay. Likewise, plural is vertices. 4 vertices. Okay. What are those? A, B, C, D. And it has 4 sides. What are those? AB, BC, CD, DA, right? And adjacent sides. Adjacent sides means nearby sides. What are the nearby sides? That is AD, AB. Is it not? These two are adjacent sides. AD, AB. Similarly, BC, CD. Okay, BC, CD. And you can also have DA, CD. DA, CD. Another set is AB, BC. Okay, so these are adjacent side. So placed nearby. Next to that, opposite side means just opposite. Okay, what are opposite sides? You can identify as AB is opposite to what? CD. Then BC is opposite to AD. Do you understand? Similarly, consecutive angles. Consecutive angles means next to that. Okay. For example, you have angle A and angle B consecutive. Okay. Similarly, angle B, angle C, they are consecutive. Similarly, angle C, angle D. Similarly, angle D and angle A. Do you understand? Next to that. Consecutive means next to next. Opposite angles are A and C. Okay. Opposite angles, angle A, angle C, angle B, comma, angle D. They are opposite angles. Okay. Diagonals are the lines that connect the opposite angles, opposite vertices. Okay. So A is a vertex, C is the vertex, opposite vertices. So diagonals connect the opposite vertices. Got it? Right. We'll discuss in the next class.